Previously in example 2.1, we had two 2D vectors that were added together to get a resultant vector. In example 2.2, we'll have a resultant vector that will resolve into its 2D components. You can see example 2.2 has been added in. And in this case, I have represented the 600-pound force with a 60-millimeter line. So all of my forces will need to be multiplied by 10. The 600-pound force is horizontal, and the u-axis is 30 degrees above it, with the v-axis being another 30 degrees above that. So to resolve our 60-pound force onto the u and v axes, we'll draw two lines. And to start, I'll go in the direction of the u vector and sort of in the direction of the v vector. So remember, this is triangle rule. To make this work, I need to make them parallel. So the u component will be parallel to the u-axis, and the v component will be parallel to the v-axis. And you can see that the sketch in Onshape has turned from blue to black, and that this is the only solution for this resultant force along these two axes. We can have the dimension displayed as 103.9. Recall we have to multiply that by 10. So the u component of the force will be 1039 pounds, and the v component will be 600 pounds. To set this up with the triangle rule, we would need to do the calculations that the v component and the resultant force have an internal angle between them of 120 degrees. We could use law of sines to get that the force in the v direction is going to be equal to the resultant force. And we could either use law of sines or law of cosines to solve for the force in u.